Welcome to the video lecture series of solid state devices. Course code is 301, contact hours 3, credits 3. Myself, Dr. Shuripa Roy, Assistant Professor of Electronics and Communication Engineering Department, Guru Nanak Institute of Technology. This is lecture 18. So this is the module 3, module content, that is module 3, device physics of bipolar junction transistor, physical mechanism, carrier distribution in forward active mode. And the last is origin of parameter in hybrid pi model, time delay factor, alpha beta cutoff frequency. So this is the lesson plan. This is the objective. Now the basic transistor operation, as already mentioned in the earlier lecture, that IE equals to IC plus IB. And beta equals to IC by IB, alpha equals to IC by IB. So we know alpha equals to beta by 1 plus beta and beta equals to alpha by 1 minus alpha. So now, what is punch through voltage? As we increase the reverse bias voltage of base collector junction, depletion width increases and effective base width decreases, since base is less doped compared to collector. Depletion layer protrudes more into the base, the collector. Hence, effective base width gets affected. At some point of time, base width approaches 0 and transistor will break down. This phenomena is called punch through or reach through. That means, if we increase the reverse bias voltage, what will happen? This is the base region, this is the collector region, and the depletion layer will penetrate more into the base region than the collector region, because the base region is less doped or lightly doped. Now, if we increase this reverse bias voltage more and more, what will happen? The width of this depletion layer increases, and it is gradually increasing, then again increasing, then again increasing. In this way, a point of time may arise when this base region is completely covered up with the depletion layer. And at that point of time, due to the forward bias applied at the base emitter region, electrons or holes, whatever be the majority carriers, will punch through the depletion layer across the base and reach to the collector region. This phenomena is called reach through or punch through phenomena, and the voltage at which this phenomena occurs is called punch through voltage. So this is some important terms discussed in terms of CE circuit, that is operating point and bias. What is operating point? The zero signal values of IC and VCE in a CE transistor circuit are known as operating point. So, more precisely, when no signal is applied at the base or at the input terminal of a transistor, still there is a value of IC and VCE we are getting that point, if we plot in the characteristics curve, we will get operating point. So biasing is related to operating point. The setting up of proper operating point is known as biasing. So if you bias, according to your bias, operating point will move up and down. So this is the basic transistor, and this is the input signal, and this is the output signal roughly, and this is the IC versus VC curve, that is output characteristic curve of a transistor when base current is fixed. If we go to the next slide, we can find that IC equals IE equals to IC plus IB. Now when VCE equals to 0, if we put here Kirchhoff's voltage law at the output loop, then we find that VCE equals to ICRC plus IE. VCE equals to IC into RC plus VCC. Now when IC equals to 0, then VCC equals to here we find that VCC equals to ICRC plus VCE. This is the formula at the output loop. Now, if we put IC equals to 0, then VCE equals to VCC. If we put VCE equals to 0, then IC equals to VCC by RC. Now, if we plot these 2 points at the y-axis and at the x-axis and join these 2 points, then we are getting the DC load line. So it is written over there. It is the line, one of the output characteristics of a transistor circuit, which gives the values of IC and VCE corresponding to 0 signal. So if we join these 2 points, we are getting the DC load line. So what is the relation between beta VBCO and beta VCEO? Answer is beta VCBO and beta VCEO are collected to base breakdown voltage with emitter open circuited and collected to base breakdown voltage with emitter open circuited. This is collector, this would be collected to emitter breakdown voltage when base open circuit, and this is collected to base breakdown voltage when emitter open circuit. The relation between these two are beta VCEO equals to beta VCBO in bracket 1 by beta DC to the power n. So what is the significance of avalanche multiplication factor in transistor? Actually, avalanche breakdown occurs due to avalanche multiplication of charge carriers. The reverse saturation current that crosses the collector junction, that is ICO, becomes M into ICO, where M is the avalanche multiplication factor. And if reverse bias voltage is increased much beyond beta VCBO, then the avalanche multiplication factor becomes infinitely large. and hence the current through the transistor rises abruptly. So what is the average multiplication factor? That is M equals to 1 by 1 minus VCB by beta VCBO to the power n. So beta VCBO is collected to base breakdown voltage with emitter open circuit. What is significant of emitter degeneration resistance? Emitter degeneration resistance refers to addition of resistance in emitter lead, which introduces negative feedback in the amplifier circuit. And some of the significant consequences of adding emitter degeneration resistance are the voltage gain decreases, bandwidth increases, input resistance increases, nonlinear distortion and noise levels get reduced. It helps in stabilizing the Q point of transistor. What is thermal runaway? Thermal runaway means if the temperature of the ambience increases, then minority carrier concentration increases. Minority carrier, why this increased? Because minority carrier generation totally dependent on the temperature. If temperature increases, then electrons or holes from the valence band jump from valence band to the conduction band due to the energy that has been taken from the temperature. Sufficient energy it has got, the charge carriers in the valence band, and it now can able to move to the conduction band. That's why minority charge carriers increases. And if minority charge carrier increases, then IC increases, because IC is the summation of collector current plus minority charge carrier current. So as IC increases, then again the transistor getting heated. That's why temperature increases. And as the temperature increases, then again ICO increases. That is reverse saturation current increases. That again IC increases. Then again temperature increases. This phenomena is continuous. This is called thermal runaway. Now, what is the condition to eliminate thermal runaway in BJT? The condition to eliminate the thermal runaway in BJT is to bias the transistor in such a way that VCE equals to VCC by 2, where VCC is the DC power supply. VCE is collector to emitter voltage. This is derived on the fact that the rate at which heat is removed from the junction should be more compared to the rate at which heat is dissipated at the junction. So a transistor can act as a switch also. When it is used in saturation mode, then the switch is on, and when the transistor is used in cutoff mode, the switch is off. So VCC is cut off, that is 0 volt in saturation, and VCE is in cutoff, then it is in VCC. When the voltage, output voltage is VCC, then it is cutoff, and when the output voltage is 0 volt, then it is the transistor is in saturation. So here are few important terms: the input resistance, the output resistance, the current amplification factor, and the voltage gain. So the current amplification factor alpha, beta, gamma. For CB circuit we know alpha, for CE circuit we know it is beta, and gamma it is nu for CC circuit, that is IE by IB. And input resistance is Ri equals to VBE by IB at constant VC. Output resistance is RO is VCE by IC at constant IB. And voltage gain is the ratio of output voltage to the input voltage, that is AV equals to del VCE by del VBE in case of CE arrangement. So here are the summary. This is the suggested book. For any question, Please ask.